Today, I am going to discuss difference between sigma bond and pi bond. In this lesson, we are going to learn characteristics of sigma bond and pi bond. So, let's get started. Let us consider an organic compound that contains both sigma bonds and pi bond. In this molecule, there are 5 sigma bonds and one pi bond here. In case of carbon-carbon double bond, here one sigma bond and one is pi bond. Let us orbital structure of this compound. This compound, carbon atoms are sp2 hybridized. Orbital structure is like this: sp2 hybrid orbitals. This carbon, sp2 hybrid orbitals. Here, overlap between sp2 hybrid orbitals happen. As a result, carbon-carbon single bond, which is a kind of sigma bond, is formed. Here, sp2 orbital of this carbon overlaps sp2 orbital of this carbon. As a result, sigma bond is formed. This bond is formed through head-to-head overlap of hybrid orbitals. Here, s orbital of hydrogen overlaps sp2 orbital of carbon. As a result, here another sigma bond is formed. S orbital of hydrogen overlaps sp2 orbital of carbon. Here another sigma bond is formed. With this carbon, s orbital of hydrogen overlaps sp2 orbital of this carbon. As a result, here another sigma bond is formed. Again, s orbital of hydrogen overlaps sp2 orbital hybrid orbital of this carbon. Another sigma bond is formed. But with this carbon, one unhybridized orbital is left. With this carbon, one unhybridized orbital is there, which is pz orbital. This pz orbital, unhybridized pz orbital overlap occurs. As a result, carbon-carbon pi bond is formed. So here, one pi bond, one sigma bond. Overlap between unhybridized pz orbital can be shown in this way. Here, sidewise overlap occurs. Through sidewise overlap of orbitals between unhybridized orbitals, pi bond is formed. So here, one pi bond, one sigma bond. This is complete orbital structure of ethene, in which sigma bonds and pi bond are present. Let us see some differences between sigma bond and pi bond. First point is definition. Definition of sigma bond: the bond which is formed by head-to-head overlap of orbitals. Head-to-head overlap of orbitals can form sigma bond. Sigma bond is formed by head-to-head overlap of orbitals, but pi bond is formed in this way. Carbon atom, unhybridized orbital, carbon atom, unhybridized orbital. So this is a kind of pi bond which is formed by sidewise overlap of orbitals. Definition is sigma bond is formed by head-to-head overlap of orbitals. On the other hand, pi bond is formed by sidewise overlap of orbitals. Then point number 2, orbital axis. In case of pi bond formation, two orbitals lie in the same axis. So this is same axis. But in case of pi bond formation, two orbitals lie in parallel axis. So orbital axis. In case of sigma bond formation, two orbitals lie in the same axis, but in case of pi bond formation, two orbitals lie in the parallel axis. Then orbital nature. Orbital nature means which orbitals can form sigma bond and which orbitals can form pi bond. Here we see that sigma bonds are formed by hybrid orbitals and hybrid and pure orbitals. So sigma bonds are formed by hybrid orbitals and hybrid and pure orbitals. That is, here carbon-carbon single bond is formed by hybrid orbitals and carbon-hydrogen single bond is formed by hybrid and pure orbitals. Here this is hybrid orbital sp2 and s orbital which is pure orbital. This orbital is formed by hybrid and pure orbitals. So orbital nature, hybrid and pure orbital. But in case of pi bond formation, except s and hybrid orbitals, unhybridized p orbitals, unhybridized p orbitals can form pi bond. So this is orbital nature. Number 4, bond type. Bond type means sigma bond is formed first, after that pi bond is formed. That is, sigma bond is followed by pi bond. That is why sigma bond is a kind of primary bond. Because sigma bond is formed first. After sigma bond, pi bond is formed. That is why pi bond is a kind of secondary bond. This is bond type. Number 5, bond strength. Here, sigma bond is formed by a head-to-head overlap. As a result, here amount of overlap becomes maximum. That is why sigma bond becomes stronger. Because here amount of overlap is maximum. bond becomes stronger. But in case of pi bond, when unhybridized orbitals overlap to form pi bond, in this case amount of overlap is minimum because here sidewise overlap occurs. That is why amount of overlap becomes minimum, and as a result pi bond becomes weaker. So bond strength, sigma bond is stronger because of the head-to-head overlap, because of the maximum overlap, but pi bond is weaker because here minimum overlap occurs. Next point is rotation of atoms. Rotation of atoms. Let us consider here, this is sigma bond and two atoms along a sigma bond, single bond. In this case, atoms can rotate freely along sigma bond axis. Atoms can rotate freely along sigma bond axis. So here free rotation is possible. Free rotation is possible. But if it is double bond, then atoms along double bond cannot rotate freely. So here rotation is not possible because in this case two bonds are present between two atoms. One is sigma bond, another one is pi bond. Because of these two bonds, the atoms along pi bond axis cannot rotate freely. If the atoms can rotate freely, then it requires to break this pi bond. Without breaking this double bond, atoms cannot rotate freely along pi bond axis. So this is the point, rotation of atoms along sigma bond axis. Atoms can rotate freely, but atoms along pi bond axis cannot rotate freely. If the atoms can rotate, then pi bond is to be broken. So these are the characteristics of sigma bond and pi bond, that is differences between sigma bond and pi bond. No more today. Thank you very much.